Welcome to my projectbazaar.com. Now let's see about automatic tuberculosis screening using chest radiographs. Now let's see about this abstract. In this paper we have implemented CT lung abnormality detection by the SVM classifier. Initially we remove the noise from the images. For filtering the images we use the VNR filter for denoising. In a second step we employ a graph cut approach and model the lung boundary detection with an objective function. Graph cut is applied specifically to those models which employ a max flow optimization. After lung segmentation, we extract three features such as LBP, HOG and Tamra features are extracted. LBP stands for local binary pattern. It is a simple yet very efficient texture operator which labels the pixels of an image by thresholding the neighborhood of each pixels and consider the result as a binary number. And then HOG counts the occurrences of gradients orientation in localized portions of an image. It also computed on a dense grid of uniformed space cells. And finally we extract the Tamra features. These features are given to the SVM classifier. The trained classifier will predict about the CT lung images. And finally we analyze about the classifier performance with the existing system. This is the flow over process. Here we come to given the input image. It will be the CT chest lung images. It will go to pre-processing stage. In pre-processing, we are applying Gaussian filter to our input image. Gaussian filter is often used to remove the noise from the image. Here we use the VNR function to our input image. After removing the noise, it will go to lung segmentation. For segmenting the lung, here we are using graph cut segmentation algorithm. It will be work on based on the graph analysis. The maximum flow of problem in a graph will be analyzed in graph cut segmentation. Based on this, the lung will be segmented. After segmenting the lung, it will go to feature extraction. Three features are calculated, that is LBP feature, Hawk feature and Tamra feature. LBP stands for local binary pattern. It is a type of features used for classification in computer vision. LBP is a particular case of texture spectrum model proposed. The binary pattern will be created. After this, the histogram feature is used from the binary pattern images. After this, we go for the Hawk feature. It stands for histogram of gradients. It is a feature descriptor used in a feature extraction technique. The technique counts the occurrences of gradient orientation in local portions of an image. After that, we go for the Tamra feature. The Tamra features will be calculate the correlation between the spatial variation of a grade level information is calculated by the use of this algorithm. These three features are combined and given to the SVM classifier. Both information are given such as normal and abnormal CT lung images features are given to the classifier. The trained classifier will predict about the abnormality in the CT lung images. Now let's have a demo for process. Here I am having main.m. Select this file, right click, run the file. This is our guide design. We have to given the input image, it should be the CT chest lung images. In data set, totally I am having 16 images. First 6 is the normal images and next 10 is the TB affected image. Now I am selecting one image as an input. This is the filter image. For filtering the image, we are using VNR filter. After this, we move for the binary session. This is the seed value. Based on given seed value, the lung will be segmented. The range of this will be 0.5 to 0.7. Now I am giving 0.5. Based on the binary image, we are mapping the result to the original lung image. This is the binary image of the segmentation. So the unwanted region is also there. So we are going to eliminate this region and also analyzing the shape from the original images. In lung identification, it will be done based on the graph cut algorithm. These are the initial parameters. You can also given the vary from 0.2 to 0.5. The process is going on. This is the process of GraphCast. It will analyze the region in the segmented lung region. This is the analyzed shape of the region of lung. It will be identified by the use of GraphCast algorithm. We go for the next for a disease identification. Initially, we are calculating the LBP feature. It is represent the local binary pattern. The pattern of the grayscale image will be identified. This is the LBP image. This is the LBP image. For the binary image, we have calculated the histogram. This is the histogram of the LBP image. These are the feature values of LBP. Next, we detect a heart feature, and then we detect a Tamura feature. These three features will given to the classification. For detecting the abnormality, here we are using the SVM classifier. The SVM is detecting this lung is normal, and these are the comparison graph. For this, we have calculating specificity with the existing and proposed classifier. This is the sensitivity graph. This is the accuracy graph. How much accuracy is there between our existing and proposed system, that is shown here. This is the classification result. Two result is there. First one is normal and tuberculosis is there. Here our classifier is predict this as a normal. Now I am showing the result of identifying the tuberculosis in the CT lung images based on the SVM classifier. It's showing the better performance than the existing system.